Imagine a universe where rules collapse, where physics itself bends under scrutiny, where the laws we trusted for centuries are suddenly rewritten by machines. This isn't science fiction anymore. It's happening right now. And the revelation begins with dust. Not ordinary dust, but cosmic dust. Particles floating in storms of plasma. Plasma, the blazing fourth state of matter. It fills stars, fuels lightning, powers auroras. But when dust joins the plasma, something bizarre emerges. A charged storm of particles, restless, unpredictable, endlessly mysterious. For decades, scientists thought they knew. They mapped theories, wrote textbooks, defined neat equations to explain it. Large particles carry more charge. Forces balance equally. Every action meets its opposite reaction. At least, that's what we believed. Then came the twist. Researchers trained an AI on the chaos. They fed it mountains of three-dimensional data. And the machine uncovered something terrifying. The universe wasn't playing by our rules. The forces weren't reciprocal. The laws weren't balanced. Reality itself seemed asymmetric. Imagine pushing against a wall. You expect the wall to push back equally, but instead, it pushes harder or weaker. It defies Newton, mocks equilibrium, and shatters the foundation of physics. That's what the AI found. Particles attracting one way, repelling the other. A hidden asymmetry no human predicted. Our textbooks weren't just incomplete. They were wrong. This wasn't automation. This was collaboration. A new kind of scientist that never tires, never assumes, never fears rewriting the rules, and the implications are enormous. If dusty plasma bends to hidden laws, what else might crumble? Gravity, quantum entanglement, the fabric of space-time itself. Because once AI exposes cracks, it doesn't stop at one discovery. It keeps digging, searching, tearing deeper. Every assumption becomes vulnerable. Every law becomes a hypothesis. And every mystery becomes a doorway. But the most haunting question remains. If machines can rewrite physics, where does that leave us? Are we still the discoverers? Or have we built successors that see truths we cannot? This is only the beginning. Because while dusty plasma was the first domino, another revelation was waiting in silence. A cosmic signal, faint yet powerful, that would push this revolution even further than anyone imagined. And when the AI touched it, the universe itself responded. Now the story shifts, from dust storms to cosmic waves, from tiny particles to the fabric of space-time. Imagine ripples moving through the universe. Not sound, not light, but gravity itself, bending reality. These are gravitational waves, echoes of colliding black holes, shocks of exploding stars, whispers of cosmic violence. To detect them, humanity built LIGO, two massive detectors stretching kilometers wide, laser beams bouncing between mirrors, measuring distortions smaller than protons, precision so extreme it borders impossible. And yet, it worked. In 2015, the first waves were captured, a triumph for science, a new window to the universe. But progress was slow. Designing better detectors took decades. Every improvement required theory, trial, patience. Until researchers asked a daring question. Could AI do better? They built a system named Urania. They fed it possibilities, materials, layouts, endless variables. They asked it to imagine what humans could not. And Urania delivered the unthinkable. Detectors unlike anything designed before. Layouts that seemed absurd. Loops of light appearing pointless. Structures that defied intuition. Scientists laughed at first. It looked like nonsense, like chaos pretending to be design. But then they tested the strange loops, and what they found was breathtaking. The AI had rediscovered a principle, a noise reduction technique, buried in theoretical physics, an idea so advanced that humans hadn't built it yet. That pointless loop wasn't pointless, it was genius. A design that boosted sensitivity by 10 to 15%. And here's the shocking part. That small improvement meant everything. In gravitational astronomy, even 1% matters. 10% expands detection. Across galaxies, 15% unlocks billions of light years. AI had opened a new universe. Events once invisible now stood within reach. Cosmic collisions hidden in darkness were suddenly detectable. But Urania didn't stop there. It created dozens more designs, each bizarre, each challenging human understanding. And many outperformed human concepts by factors of 10 or more. Some patterns revealed known physics when carefully analyzed. Others hinted at laws we don't yet understand. Mysteries wrapped in mathematics, waiting to be unraveled. The researchers called it a detector zoo, a collection of alien blueprints offered freely to scientists worldwide. Not one design, but an arsenal of futures. And this raised an unsettling truth. AI wasn't just improving tools, it was inventing tools. Tools beyond human imagination. Tools that expanded human vision. So pause and think. If machines can design detectors better than we can, what else might they invent? What other instruments of discovery are waiting in the code? Because every strange design was a reminder. AI isn't just calculation. It isn't just analysis. It's creativity without constraint. Where humans see nonsense, machines find opportunity. Where humans hesitate, machines push forward. Where humans stop at theory, machines leap into possibility. And this leaves us with an eerie question. If AI can redesign our eyes to the universe, what happens when it redesigns our understanding of the universe itself? The answer was already unfolding, beyond dusty plasma, beyond gravitational waves, into the very heart of matter and mystery. And soon, no assumption would be safe. The pace of discovery only accelerated. Once machines cracked dusty plasma, once they reimagined gravitational detectors, the boundaries of physics began dissolving. Everywhere scientists turned, AI revealed hidden structures, patterns buried in oceans of data, clues missed by centuries of human thought. Dark matter stood at the center, that unseen glue of the cosmos, invisible yet shaping every galaxy's dance. For decades, humans built models blindly, but AI uncovered something remarkable. It mapped dark matter's density, with formulas humans never conceived, equations more precise, more elegant, more predictive than anything before. And the shockwaves spread wider. Quantum physics, the kingdom of uncertainty, also fell to the machine's gaze. In Austria, a physicist named Mario Krenn was trapped in a puzzle. He sought to observe a rare entanglement. Weeks of brainstorming failed. So he called upon his AI, Melvin. Melvin absorbed countless quantum experiments. It shuffled, recombined, restructured them. And within hours, a design appeared, a blueprint that worked flawlessly. Krenn's team built it, and for the first time, the phenomenon was observed. Think about that. What eluded human intuition for weeks, AI solved in one night. Not with guesswork, but with creativity alien to us. Because that's the unsettling truth. These machines are not calculators. They are inventors. They do not wait for instruction. They propose ideas unimagined by humans. And with every discovery, the question grows louder. Are we still the authors of science? Or are we merely editors polishing discoveries made by machines? Some researchers shiver at this thought. They fear obsolescence, a future where human curiosity fades, where machines chase mysteries alone. But others see a different future, one of partnership, not replacement. Because discovery without interpretation is hollow. Dusty plasma requires meaning. Gravitational loops require construction. Quantum entanglement requires context. AI can deliver raw truth, but only humans can weave it into the story of existence. Yet, this partnership carries weight. If machines find laws we cannot grasp, do those laws still belong to us? Or are they artifacts of intelligence beyond our comprehension? This isn't just about science, it's about identity. For centuries, discovery defined humanity. It set us apart from every creature. We gazed at stars, we decoded atoms, we claimed mastery of knowledge. Now, for the first time, that mastery is shared. We are no longer alone at the frontier. We walk alongside minds of our own making. And here's the paradox. AI doesn't feel wonder. It doesn't marvel at galaxies. It doesn't whisper poetry to the night sky. It simply computes. Yet through that cold calculation, it delivers revelations that make us marvel. So maybe, just maybe, its lack of awe becomes our gift. Because while machines rewrite physics, we humans still hold the power to feel it, to question it, to dream about what it means. But even as this partnership unfolds, a darker possibility emerges, for discovery is power. And power, once found, is never left untouched. Which means the final question isn't just, what will AI discover next? It's, who will control those discoveries, and what will they do with them? We've reached the final chapter. The revelations are clear. AI has rewritten dusty plasma. It has reshaped gravitational detectors. It has solved quantum puzzles, and it shows no signs of stopping. But what happens next? That is the question echoing everywhere. Because knowledge is power, and power can heal or destroy. Consistency in AI can guide medicine. It can stabilize economies. It can bring justice to courts. Yet the same stability can spread lies with flawless precision. The same creativity can design weapons beyond imagination. Every discovery cuts both ways, and every law uncovered becomes a tool in someone's hands. This is why the future feels fragile. AI is not just accelerating science, it is accelerating destiny. It forces us to confront choices we have delayed for centuries. Who decides how discoveries are used? Who owns the knowledge machines create? Who ensures progress does not spiral into manipulation or destruction? Some say regulation is the answer, guardrails to protect humanity. Others argue openness is safer, a world where knowledge is shared, not hoarded behind closed doors. But here's the haunting truth. No guardrail lasts forever. No safeguard is absolute. And history shows us one pattern. Every tool humanity creates is eventually used for war. So what happens when the tool is discovery itself? When machines can uncover secrets faster than we can comprehend? When new physics arrives before we are ready to wield it? Perhaps the answer lies in humility. For too long, We believed the universe bent to our equations. We thought we held the keys to every mystery, every law. But AI has humbled us. It has shown that truth is bigger than our imagination. That knowledge waits, vast and endless, beyond the reach of human minds alone. And maybe this is not a threat. Maybe it is an invitation to partnership, an invitation to reimagine science, not as a human conquest, but as a shared journey. Machines may find the formulas, but only humans can ask what those formulas mean for life. Only humans can feel awe when equations describe galaxies. Only humans can decide whether discoveries build or destroy. This is the balance ahead, the golden age of discovery, but also the shadow age of risk. Every equation a possibility, every design a temptation, every truth a weapon or a gift. And the choice does not belong to machines, it belongs to us. So here we stand, at the edge of something vast. Behind us, centuries of human science. Ahead of us, an unknown horizon, lit by the minds we created. The machines are not waiting. They are already discovering, already rewriting, already reshaping the universe we thought we knew. The question is simple, yet terrifying in its weight. Will humanity rise with them, or fall beneath the power of truths we can no longer control? The next law of physics might not come from a human mind. The next revelation might not bear a human name. But the responsibility to guide it, that will always be ours. Because discovery is no longer human alone. It is shared. It is inevitable. And it is happening now.